Mean absolute deviation. I'm going to go over a couple of things about mean absolute deviation, and the first thing I'm going to do is I'm going to talk about what it is and what you're going to have to do. So mean absolute deviation is a number. Whew, my pen is super thick. Let me fix that. So it is a number, okay? And your job is to calculate that number. And so what it is, what is it? And I'm going to use the next couple of graphs to explain what mean absolute deviation is. Okay, so you have seen this graph before, but I pulled it back up because I am going to go through, remember how we did our line of best fit where we drew the railroad tracks? And then we took and we drew halfway in the middle of the railroad tracks. Mean deviation, mean absolute deviation talks about the spread. Okay? So basically it is talking about how wide this is. Okay? Because in some graphs the sides of the railroad tracks were pretty far apart. And this one it is, and some of them they're pretty close together. So the smaller the mean absolute deviation number that you guys are going to calculate is, the closer the data is to a linear function. So let's go on these two. Okay? And so if this was a set of data and I asked you to calculate this set of data, calculate the mean absolute deviation from this set of data. Okay, so I'm going to do the railroad tracks. Okay, and I'm going to do the railroad tracks. Now, this one is wider, and so the mean absolute deviation value is going to be a higher number. These railroad tracks are smaller, and they are closer clumped together, so the mean absolute deviation is going to be pretty close to a pretty low number. Okay, so the higher the number, the more spread out the visualization of the dots. Okay, here again, you would expect a very large or a larger mean absolute deviation, pretty spread apart. And what it's talking about, oops, didn't do that in red. Doesn't have to be in red, but it helps you guys visualize it. That's the line of best fit, and those dots are pretty far spread out. Now, here, it doesn't just you don't just get to calculate mean absolute deviation from positive correlations. You can also do it from negative correlations. Okay? And notice that this has a pretty wide spread. And the bigger the number, the wider the spread. Okay? I noticed we couldn't draw railroad tracks, so the mean absolute deviation number is going to be quite large. So when I'm going to teach you how to do the mean absolute deviation, but the smaller the number, the closer they are. The larger the number, the more spread out they are. And we're talking about the distance and the spread about the dots. And so your job is to calculate the mean deviation, which is a number. And just to help you along and kind of visualize your numbers, it's the distance and the spread of the boundaries of the railroad tracks.